Alright. What did one eye say to the other eye? Oops. Come on, Ben. What did one eye say to the other eye? Don't look now, but something smells. Something between us smells. There we go, I can't read it. Don't look now, but something between us smells. Do you get it? The nose? Because the nose smells. Like it actually smells. Alright. Going on to your frame today. In your frame, we have your key topic, which today is horizontal and vertical lines. Pen. There it goes. Why aren't you working? Alright, sorry about that. Horizontal and vertical lines. Horizontal and vertical lines is or are about knowing the characteristics of these special lines. Alright, so it's about knowing the characteristics of these special lines. Alright, so here we go. We're going to go to the next slide. Then my pen is going to start working. Okay, so on this slide, on your first example, you already have a line going. This is a vertical line, like a vertical jump, so shot goes up. So if we just find some points on this line, like this point right okay, I'm just laughing my pen. There we go, like that point and this point. If we just put these points into an x, y table, your x is 3, and let's do this one as 3. Then here your x is 3, your y is 2, your x is 3, your y is 1, your x is 3, your y is -1. So when we write the rule for this equation, the rule is x is always 3. So in order to show that x is always 3, we just say x equals 3. X is always 3. Alright, that's another way of reading it. Here we go to the next one. We have x is always -5. If you make an xy table, which you should be doing with me, our x always has to be -5. X is always -5. It doesn't say anything about y, so y could be 0. X is always -5. Y can be whatever. Let's say 1. X is always -5. Y can be whatever. Let's say -5. Alright, so if we plot these points, we have -5, 0, which means we go to the left -5, stay there. We have -5, 1, -5, that's 5 left, up 1. And -5, -5, left -5, down 5. Alright, so then we just draw our line straight through them. And we get a nice vertical line. Beautiful. Alright, here we go to the next one. They were on the other side now, the right side, and I just drew a random line. Ignore that. Okay, on this one, we have to write the rule for it. So if we make an XY table, we're going to find some points on this line and jot down those points. So here's a point, and here's a point. So here our x is -2, and our y is -2. Here our x is 0 because we didn't move anywhere, but our y we still went down 2, so -2. Here our x is 4, and we went down -2. So for the rule for this linear function, it doesn't ever really matter what x is. Our y is always -2, so we're going to write y is always -2. And underneath this, I want you to write down y is always -2. That's one way of reading it, and it helps you really graph that. So if we go to the next one. Alright, now on our second problem, we want to make sure this y is by itself before we do anything. So we're going to draw our line down the middle. We want to solve for y, so we have to get rid of this adding 2. So we subtract 2 from both sides. So we end up with y equals 6 minus 2 is 4. So we have the equation y is always 4. So when we make our table for xy, our y has to be 4. Usually we always work with our input, our x first, then get the output. In this case, we get the output first, the 4. So it doesn't matter what x is. X could be -2. X could be 3, and we still get 4. X could be 5, and we still get 4. So if you plot these points, we have -2, which is left 2, up 4. Then we have 3, 4, which is right 3, up 4. And we have 5, 4, so it's right 5, up 4. Alright, then we just draw our line through it. And we say it's good. Alright, our so what? Oh, I don't know why I'm writing so what. Our so what, when it says x equals, that means x is always. And when it says y equals, that's a way to say y is always. Alright, tomorrow we're going to make a fun little ditty with this. Go ahead and take the quiz. Thank you. Bye.